Hello, in this video we will use what we learned in the previous video, which is approximation by increments, to solve a problem. So the problem actually reads as follows. Suppose the total cost in dollars of manufacturing Q units of a certain commodity is C of Q is equal to 3Q squared plus 5Q plus 10. If the current level of production is 40 units, so the current level of production is 40 units. That means that Q is equal to 40. Estimate how the total cost will change if 40.5 units are produced. So our delta Q is 0.5. Agreed? Because that's 40.5 minus 40, which is our change in Q. Very well now, so we have all the information we need. We just now have to use our approximation by increments rule to figure out what this approximates to. So we could have just plugged in the 40 as Q and then 40.5 and find the difference. However, this is a very simplified example. Not all of the times is so easy just to plug into numbers and compare them. It actually takes time, and it actually takes a lot of computations to do it, and it's just easier to use the approximation by increments, finding the derivative of the function. So as you might recall, our approximation by increments is that f of x naught plus delta x is approximated by f of x naught plus f prime of x naught times delta x. And so by doing so, we find that f of 40.5, which is our x naught plus delta x, also just as a quick note, so if we wanted to see how much would it change if we decrease it to 39.5, our delta q would be negative 0.5. So you need to keep the sign to know if it's increasing or decreasing, because the change would be different. And so in this case we know that it's positive 0.5. And so this is approximated by f of x naught. So using 40, calculating this formula with 40 is a lot easier than doing it with 40.5 or any other number. So that's also one of the reasons that we are okay with doing this and not with doing it the obvious long way. So if we solve for C of Q when Q is equal to 40, we get that this is equal to 5010. And so we find that f of x naught is 5010. And then f prime of x naught, so we find C prime of Q. That's just equal to 6Q plus 5. And so 6 times 40, that's 240, so 245 times 0.5, which was our change. And so this is approximately equal to 2.5, right? And so 0.52315. So 5,132.5. That is approximately what the change would cost. So if we want to know, actually, we were asked for the change itself. So we know that the change is actually just f prime of x naught times delta x, because if we want to know the change in f of x given a change in x, well, we know that is just equal to f prime of x naught times delta x. Why? So let's see why. We know that f prime of x is equal to the limit as delta x approaches 0 of f of x plus delta x minus f of x over delta x. However, we know that f of x plus delta x minus f of x, if you remember when we, on the very first video about derivatives, when we were trying to define a derivative, we said that this is just the change in f of x, right? Which is right. It's very clear from what we have here that that's the case, and so we can just rewrite it as f of delta f of x. And so by having the requirement that we mentioned in the previous video that we have delta x very small, very close to 0, so we can get rid of this, and here we just put the approximation sign. And so to get delta f of x just in one side, we multiply both sides by delta x, and we get f prime of x times delta x is approximately equal to the change in x. And so we actually didn't need to find f of x naught on the first place, but it was in case you also wanted to find what the function would be at 40.5. But since we were only asked for the change, this was enough, and it's 122.5.